In space, one of the most surprising discoveries is a new magnetic field at the edge of interstellar space. Scientists had believed the Sun's magnetic influence would fade away as Voyager crossed the heliopause, the boundary where the Sun's influence ends, but instead, the spacecraft found a stronger and more complicated magnetic force. This finding challenges everything we thought we knew about the outer edge of the solar system and the environment beyond. The importance of this discovery goes far beyond just scientific curiosity. It affects how we might protect Earth from harmful cosmic radiation and what possibilities exist for space travel in the future. Could this newly found magnetic force provide opportunities for us, or does it reveal dangers we don't yet understand? What Voyager has uncovered is much more groundbreaking than anyone had predicted, and this won't be the last discovery to leave us amazed. Cosmic rays, which are high-energy particles linked to violent cosmic events like supernovas, are another unexpected finding. As Voyager entered interstellar space, it detected a sharp increase in cosmic ray intensity. The solar system's protective shield, which was once thought to block much of this radiation, seems weaker than scientists had expected. This raises troubling questions. Are future astronauts ready to face this type of radiation? Could these cosmic rays point to an even larger, hidden threat in the universe? These discoveries show just how little we know about the environment beyond our solar system and emphasize the risks of exploring farther into space. The data also reveals a chaotic mix of magnetic fields and plasma at the heliopause, which goes against the long-held idea that this boundary would be smooth and predictable. Instead, Voyager's instruments have found strange and unpredictable changes that don't match current scientific models. These irregularities might point to forces we don't yet understand, with consequences not only for space exploration but also for Earth's safety. As organizations like NASA and private companies such as SpaceX plan missions to Mars and beyond, these findings show that we need to rethink how we approach interstellar missions. For decades, Voyager has been a symbol of human ingenuity and exploration. Its unexpected discoveries highlight the spacecraft's incredible durability and the brilliance of the scientists who built it. Even though Voyager is so far away that its signals take almost a day to reach Earth, it continues to send back valuable information. This accomplishment shows the careful engineering and planning that went into the mission. However, there are questions about how much longer the spacecraft can keep working, as its power supply is running out. We may soon lose the important information Voyager is providing. Despite these challenges, Voyager's discoveries could transform how we understand the universe. The strange things it has found, like changes in magnetic fields and unexpected radiation, might give us clues to develop new ways of powering spacecraft or protecting them. These breakthroughs could make space travel safer and more ambitious. But these discoveries also make us face the harsh realities of deep space. What if these forces aren't just things we study but real threats to human survival in space? How can we balance our desire to explore with the need to stay safe? The increase in cosmic ray intensity near the heliopause isn't just a challenge for future astronauts. It could have wider effects. Higher radiation levels might disrupt Earth's satellite systems, GPS networks, and global communication. Imagine a world where the technology we rely on every day becomes unreliable, all because of forces coming from deep space. These risks show how connected space and Earth really are, and they underline the need for strategies to deal with these challenges. Ethical questions are just as important. Should we keep pushing the limits of space exploration when we know so little about the dangers involved? Voyager 1 probe, the most distant human-made object in the universe, is once again sending usable information to Earth. Currently, it is transmitting what is known as health and engineering data, essentially checking if everything else is functioning. Voyager has recently sent back signals that reveal space isn't as quiet and calm as once believed. Instead, it is alive with shocking forces. After traveling more than 14 billion miles, Voyager 1 has crossed into interstellar space, uncovering intense magnetic fields and strange energy waves. One of the most stunning revelations is a new magnetic field at the boundary of interstellar space. Scientists had thought the Sun's magnetic influence would diminish as Voyager crossed the heliopause. However, the spacecraft found a stronger, more complex magnetic force. This discovery challenges everything we thought we knew about the solar system's outer edge and the interstellar environment. The implications go far beyond academic curiosity. They touch on how Earth can be protected from cosmic radiation and what might be possible for future space travel. Could this newfound force present opportunities, or does it signal dangers yet to be understood? In addition to the magnetic forces, Voyager has uncovered other groundbreaking findings. Cosmic rays, high-energy particles linked to violent cosmic events like supernovas, are another surprising discovery. As Voyager passed into interstellar space, it encountered a spike in cosmic ray intensity. The solar system's protective shield, which was once believed to deflect much of this radiation, appears weaker than previously thought. This raises unsettling questions. Are future astronauts prepared for such radiation? Could these cosmic rays signal an even larger, unseen threat lurking in the universe? These findings highlight how little we know about conditions beyond our solar system and underscore the risks of venturing deeper into space. The data also reveals the chaotic interplay of magnetic fields and plasma at the heliopause, contradicting long-held beliefs that this boundary would be smooth and predictable. Instead, Voyager's instruments have detected bizarre fluctuations that defy current scientific models. These irregularities may represent forces not yet understood, with implications for both space exploration and Earth's safety. As space agencies like NASA and private companies like SpaceX push toward Mars and beyond, these findings demand a reassessment of how we approach interstellar missions. For decades, Voyager has been a symbol of human ingenuity and exploration. Its unexpected discoveries underscore the spacecraft's remarkable resilience and the brilliance of the scientists who designed it. Even at a distance where signals take nearly a day to reach Earth, Voyager continues to transmit valuable data. This achievement highlights the meticulous engineering and planning that went into the mission, but it also raises questions about how much longer the spacecraft can operate. With its power reserves dwindling, we may soon face a gap in the vital information Voyager provides. Despite these challenges, Voyager's findings could revolutionize our understanding of the universe. The anomalies it has uncovered, from fluctuating magnetic fields to unexpected radiation levels, might hold clues to unlocking new propulsion methods or protective technologies. These advances could pave the way for safer and more ambitious space exploration. However, the discoveries also force us to confront the harsh realities of deep space. What if these forces aren't just phenomena to study but active threats to human survival in space? How do we balance the drive for exploration with the need for safety? The rising cosmic ray intensity near the heliopause isn't just a problem for future astronauts, it has broader implications. Increased radiation could disrupt Earth's satellite systems, GPS networks, and global communications. Imagine a world where the technology we rely on daily becomes unreliable, all because of forces from deep space. These risks emphasize the interconnectedness of space and Earth, and the urgent need for comprehensive strategies to address them. The ethical questions are equally significant. Should humanity continue to push the boundaries of space exploration when the dangers are so poorly understood? What responsibilities do we have to the astronauts who will face these risks? Voyager's path also challenges our understanding of the interstellar medium, the matter and energy that fill the space between stars. Its instruments have detected irregularities in how solar wind interacts with cosmic dust, hinting at forces we've never encountered. Could these forces be remnants of ancient cosmic events or something entirely new? The answers could redefine our understanding of the universe's structure and history. They also bring uncertainty. If these forces are more dangerous than anticipated, they could jeopardize missions to the Moon, Mars, and beyond. Yet, it's not all doom and gloom. The data Voyager sends back could help scientists develop technologies to mitigate these risks. For example, understanding the behavior of cosmic rays and magnetic fields might lead to innovations in spacecraft shielding or radiation protection. These advancements could make long-term space travel safer and more feasible. Additionally, studying these forces might reveal new methods of propulsion, allowing spacecraft to travel faster and farther. In this way, Voyager's discoveries are both a warning and an opportunity. The urgency of these revelations cannot be overstated. As private space ventures and national space agencies ramp up their ambitions, the risks highlighted by Voyager demand immediate attention. Missions like SpaceX's push for Mars colonization or NASA's Artemis program to return humans to the Moon must account for the harsh realities of interstellar space. The stakes are enormous. If we fail to address these challenges, the consequences could be catastrophic, both for space exploration and life on Earth. The Voyager missions remind us that exploration comes with risks and rewards. Their findings challenge us to think bigger, adapt faster, and prepare better. As humanity stands on the brink of a new era in space, Voyager's legacy serves as both a guide and a caution. The universe is vast, unpredictable, and full of wonder, but it's also a place of immense danger. The question isn't whether we'll continue to explore, but how we'll ensure that exploration benefits all of humanity. Voyager's greatest contribution may not be its data but the questions it forces us to ask. What else is out there waiting to be discovered? Are we ready for the challenges that come with venturing into the unknown? And perhaps most importantly, how can we use this knowledge to secure a better future for Earth and beyond? The answers to these questions will shape the next chapter of human history, one written among the stars. What Voyager found makes us wonder about how humans first started exploring space, and what they learned along the way. Humans have always been drawn to the stars, staring up at the night sky and wondering what lies beyond. But let's be honest, for most of history, all we could do was guess. Then came the 20th century, and suddenly, technology gave us the tools to actually go there. Rockets, giant, roaring machines, made it possible to escape Earth's grip and venture into the great beyond. The real game-changer happened in 1957 when the Soviet Union launched Sputnik 1. This little metal sphere didn't do much, it beeped as it orbited Earth, but it was enough to send shockwaves across the globe. For the first time, humans proved that they could place something in space, and that opened the floodgates for exploration. 4 years later, Yuri Gagarin, a Soviet cosmonaut, became the first person to leave Earth. His trip around the planet lasted 108 minutes, but it changed everything. Humans weren't just looking at the stars anymore. We were part of that vast universe. Not to be outdone, the United States jumped into the space race. In 1961, Alan Shepard became the first American to reach space, though his flight was brief, just 15 minutes. A year later, John Glenn orbited Earth 3 times, showing the world that America was serious about this whole space thing. These missions, part of NASA's Mercury program, were all about figuring out if humans could handle space and survive it. Spoiler alert, they could. The rivalry between the United States and the Soviet Union pushed space exploration to new heights. In 1963, Valentina Tereshkova became the first woman to orbit Earth, spending 3 days circling the planet 48 times. It wasn't just a win for the Soviet Union, it was a huge step for women in space. But the most iconic moment of the space race came in 1969 when NASA's Apollo 11 mission landed astronauts on the Moon. Neil Armstrong's words, "That's one small step for man, one giant leap for mankind," were broadcast to millions. It wasn't just a moon landing, it was a declaration that humans could dream bigger than ever before. After the moon landings, the focus shifted from quick trips to long-term stays. In 1971, the Soviet Union launched Salyut-1, the first space station, allowing cosmonauts to live and work in space for extended periods. NASA followed with Skylab in 1973, where astronauts spent missions lasting up to 84 days. These floating labs were more than just cool hangouts. They were stepping stones for future exploration.